Welcome to this next video, our assignment number 10, Debt Literacy. If you haven't taken time to read the assignment, I'd recommend doing that right now. So in this assignment, you will be answering these questions at the bottom. Need to do a simulation with 100 trials, part B. Part D, a histogram with 1,000 trials of the simulation. And then part F, you are going to do by hand. So what I'd like you to be doing, the reason for this assignment, I want you to be able to see the comparison between answering a significance test with a simulation and answering a significance test by hand. Now, most likely on the AP exam, you'll have to do it by hand, but it's very common to be given a dot plot, whether a histogram or a dot plot, and be asked to interpret the simulation. So I hope this assignment will help you see where the dot plot, where the histogram comes from. So main information, we took a survey about debt literacy. 354 out of 1,000 respondents chose the correct answer, so that's 35.4%. And right here the question is there evidence, is there convincing evidence that the proportion is less than 40%? So obviously 35% is less than 40%. However, is that due to sampling variability? Did we just so happen to pick 1,000 people in our random sample that got it incorrect? Or is there actually something going on here? Those are your two main explanations. Either A, sampling variability, or B, there actually is something going on. So let's open up I'm going to use my little editor window over here whenever I get code that works well. So what we have to start with is an imaginary population. Our imaginary population is going to have 40% that could correctly answer the question. So we'll just call this POP for population. And we need a lot of people. 40% of them can answer it correctly, 60% can't. So what we're going to do is use the C option, and then open parentheses, and then the REP for repetition. We don't have to keep typing that. And then quotes, we'll do correct, end quote, comma, and since we're going to be sampling 1,000 people from this population, let's make it a total of 100,000 people. So 100,000 people, we want 40,000 people. So 40 and then 3 zeros after it. 40,000 people will be able to correctly identify it. Close that parenthesis. And then comma, use the REP or repeat option again. And then quote, not correct. These are the people who didn't answer the question correctly. And do a comma, and that's 60,000. Now again, I'm doing this because I want to make a population. We're assuming our null hypothesis is true. We're assuming the population has 40% that can answer it correctly. And we're using these big numbers because we're going to be taking a sample from this population. We're going to take a big sample, 1,000 people. So this is why we have 40,000 and 60,000. And hit enter, make sure everything went right, and that's good. Now I'm not actually going to type POP and hit enter because it's going to give me a bunch, 100,000 corrects and not corrects. What you could do just to make sure it worked right, you could do head and then POP. And that'll show you just the first 5. So really the first 40,000 say correct, and then the last 60,000. So you could do tail, POP. And then those are the last 6. I guess it actually was 5, and then, or 6 and then 6. So head is just the first 6, and then tail is the last 6. Not that that matters too much, but you could see that it worked. Now we want to take a sample of sample from POP, from our population, comma, and we want a sample of 1,000. Now when we hit enter, we are going to see 1,000 in our sample, and this is sampling without replacement, which is what we want. And if I hit enter, I should see a bunch. Right here you could see you have 1,000. The 1,000th person was not correct, and you have a lot of options here. So whenever you do your printout, please do not include all of that. It's unnecessary. But it worked. We took a random sample from our population, and we got a bunch of corrects, not corrects. Now we don't really want to have to count all those, so we can have R do that. If you hit the up arrow, we have a sample from the population. We want to know when that equals correct. So if we hit equals equals and then quotes correct, that's going to tell us how many times it's, that'll actually say if it's true or false, if the person answered correctly. So actually what I want to do is go back to the beginning of this line of code right here, and I'm going to type at the beginning of it sum and then open parentheses. And I'm going to go back at the end and close that parentheses. So what that's going to do is it's going to sum up all the times in this sample that we got people who identified as correct. So if I hit enter, I should see a number, 383. So sample of 1,000, 383 or 38% answered correctly, assuming the null hypothesis is true. And then we want to hit the up arrow. We actually want these as proportions. So to get it as a proportion, I just need to divide at the very end of this, after the close parenthesis, divide by 1,000 and hit enter. And it's going to give me a proportion. Now it might not be 0.383 because R is going to take a new sample and it's actually 0.379. If I hit up again and ran that code, it should give me a different sample proportion, which it does, because it's taking a different sample. Now what we want R to do is plot on a dot plot this line of code. And we want R to be able to do this as the assignment says over here. The assignment says you want 100 trials of the simulation. So far we've set up R to do 1 trial of the simulation. But as you know, samples vary and statistics vary, and we want to know how much they vary. We want to know, is this number right here, 354 out of 1,000, how likely is that to happen just by random chance? So we'd like to use the replicate option. So I'm actually going to keep this since it worked really well. I'm going to highlight that, copy it, put it over here, paste that. And since I'm talking about a pop in here, maybe I'll go back way to the top. Where was it? Right here is where I defined the population. Copy that, put that over here. So far, just in this code over here, I could just run both of these lines. I identify the population, and then I take a sum of a random sample. So that's the type of code that you would include at the very end. You don't have to include all this kind of in-between stuff as I'm showing you how to operate it. But if we use the replicate, one of my favorite, we want to repeat this process of taking a sample from our population and finding the proportion who answered correctly. We want to do that 100 times. So 100 then comma. And I'm just going to copy all of this. You don't want the greater than arrow there, just the blue part. So I'm going to copy that. I'm going to paste it right here. And when I hit this, it should show me 100 sample proportions, sampling 1,000 people from this imaginary population we have. So if I hit enter, I should see 100 different. Notice they are varying. You know, some are identical, but you know you did it wrong if you get the exact same number every single time 100 times. So all we need to do now is graph this. Now this is the approximate sampling distribution of our sample proportion of people who would answer correctly this debt literacy question. So what I like to do is, I'm actually going to copy that since it worked well. Copy all that. I'm going to put it over here, right down here. And I would like to name it some variable and it'll make the code look easier. So if I'm over here, hit the up arrow, I'm going to type, I like simul, and I'll call it simul 100 just to remind myself that I'm having it do this simulation 100 times. And if I hit enter, I shouldn't see anything, which no red is always good. I don't see anything, so now we just need a dot plot. So you might remember, maybe not, but it's called a strip chart, not a dot plot. And simul 100. And we have to do method equals quote and then stack. And this should give us a dot plot, and it's stacking the dots if they happen to have the same value. And I hit enter, and I should see a dot plot, or a, little boxes as dots. So we are going to clean this up a little bit. I'll show you how to do that. But ultimately, even just this simulation, you could answer the question with that much of the simulation. I would like you to clean it up a little bit. But the question you're going to be answering is, does the sample statistic of p hat equals 354 over 1,000 give us evidence against that assumption? So on part C, at this point you can use the dot plot to answer the question. So if we go back to this, I'm going to make this a little smaller so I can see what's going on. Maybe that's too small. And make this smaller. Make this one smaller. Make this one bigger. There we go. So just to clean this up a little bit, a couple tips. So I just hit the up arrow to retype everything. So if you put comma PCH equals 16, those will give you dots, filled in circles if I hit enter. That looks a lot nicer than the first one. Other ways, you need a label at the bottom. So the X label equals. These are all sample proportions. Sample proportions, assuming the null hypothesis is true. And you could hit enter and you can see it written down there. If you want to change the color, you can do that kind of thing. Now just note that if you're working with your neighbor on this assignment, you're going to get different dot plots. You're going to get different dot plots because their R is taking different samples than your R might be. So everyone's dot plot should look different. Okay, so that was the dot plot. The second part, get rid of this dot plot. The second part says you want 1,000 trials of the simulation. So let's go back here. I have a lot of code over here in this box. While I'm thinking about it, I better save this since it worked well. Put that over here. Okay, so now I just need this replicate command right here. If you copy that, put it farther down, and this 100, I just need that to be 1,000 now instead of 100 because I've asked you to do 1,000 trials. And maybe I should go back up here. I forgot to copy my simul. So we'll put simul right after that. There we go. So when I replicate 1,000 times, I don't really have to change anything else. Notice the difference. Maybe I should point this out. This 1,000 is how many is in one sample. This 1,000 is how many sample proportions you're taking. So they are different 1,000s there. I'll name this simul 1000, and then I'll run this. On a Mac, it's Command Enter. I believe on Windows, it's Control Enter. Correct me if I'm wrong. So it's over here now. Now R has stored simul 1000. So now I just need to do a histogram of simul 1000. And I'm just going to hit enter to see if it worked well. Make sure I did everything right. And I should see a histogram when I hit enter. And there's a histogram. Size it up a little bit. There we go. At this point, you could answer the question. It might be a little difficult, but definitely helpful. If you go back to your hist simul 1000, do comma, and if you do labels equal t, that should put the numbers, how many observations are in each class of the histogram. So now you can see that. That will be really helpful as you answer the question from the assignment. Notice you can't really see this number, I don't know the highest bar there, but if you just make it as big as the screen, you can see it's 251. So obviously you could do XLab. These are also XLab equals sample proportions. Whoops. Proportions, assuming the null hypothesis is true. You could even do better context, sample proportions of what U.S. adults who would answer correctly this question about debt literacy. And that is your histogram that you'll use. I'll get rid of this. That's your histogram that you'll use on part E. So that was just showing you how to do D&E. A well-labeled histogram, and use the histogram to answer the question. Make sure as you answer the question that you reference the histogram and its main characteristics. Part F and G you will be doing by hand, not with R. There is a way to do it on R, but I want to make sure that you know how to do this by hand. And make sure you attach your code all at the end of your assignment. Hope this was helpful. Enjoy working with R.